Hello everyone, March 20th. It's a Saturday. Can't wait to see what we have today. First check this. Nothing of concern. All right, let's take a look. We had a good one yesterday. Easy one. So I'm ready. Take a look. Oh my god. Look at the name. Design underground system. Oh. Okay. Okay, this is a different type of question. It's actually every time this type of question shows up, it's always interesting. It's a real life application. Let's take a look. So we have to implement a underground system. It's a class for underground system. I guess it's for the trains, right? Underground train, the metros. We have check-in function. A customer with a card. Oh, this is interesting. Customer with a card. ID equal to ID gets in the station name at time t. A customer can only be checked into one place at a time. Okay, one place at a time. So one place and at a time. So one place, one time for each check-in. Check out with a card. Get out from the station at a time. Most likely, it's checking out at one place at a one time. Unless you can split yourself and do it at two places at the same time. But I don't think we're considering that here. Get average time returns the average time to travel between the start station and the end station. Okay, start and end. The average time is computed from all the previous traveling from start to end that happened directly. So if the station is not an end station, but say intermediate, right? We're just passing by, it doesn't count, so it has to be directly. Call to get average time is always valid. You can assume all calls to this and that, check in and check out, are consistent, which means if a customer gets in at time t1, they get out time t2, and t2 is larger than t1, okay? All events happen in chronological order, okay? Let's take a look at the example. So we create an underground system. We check in. First one, check in at, so ID is 45. Station is Layton. And time is 3. So check in at this will be easier. Check in another one, another customer, 32. Customer 32, check in to Paradise. And time is 8. So the time is going, okay, increase in time. And next one is Layton again. And a Waterloo, Cambridge. This feels, you know what this feels like? This feels like CPU scheduling, honestly. All right, let's see. Get average time, Paradise to Cambridge. So we have Paradise to Cambridge. Oh, we have it. So it's 22 minus 8, it's 14 minutes. There's only one travel. Okay, and then from Layton to Waterloo, we have 45, so 3 to 15, and 27 is 10 to 20. So that's what 10 is a 12, 10, 12 is 11. So this return 11, there are 2 travels. Okay. Yep, and then we check another one. The 24 Layton, another one. Oh, now we go Layton to Waterloo. So we have 3, right? Because we have, oh no, this one hasn't reached Waterloo yet. So it's just check in. So this one's still 11. And then now, number 10, check out the 38. So that's 14 minutes. So we're going to do, what, 11 times 2 plus 14 divided by 3. So 22 plus 14, that's 36, so 12. So this one gives 12, okay. I don't really think this is that hard by just reading about it. Check it again. Layton Paradise will be 5. Layton to Paradise will be, I was going to say 6. It's not 5.5. Layton to Paradise is 11, so we add it to it. Okay. All right. At most 20,000 operations. We have ID and T. Okay, string consists of uppercase and lowercase English letters and digits. Station name dot length will be this. Answers with 10 to the of the actual value will be accepted as correct. Okay, so we basically just need to keep a record of where people got in and where people got out. So every time a customer, because remember, the customer ID is unique, right? It didn't say, but I think it's unique. Yeah, because each customer has a unique ID. So when a customer shows up, we record its ID as the key in the dictionary, and then we record its not its, the customer's start station and start time. When the customer check out, we record its exit time and exit. So when that happens, we know one trip, right? We know one trip. So we need to also keep a tuple. We keep a tuple from start to end, right? We need to keep a tuple from start to end. So when that happens, we can remove this customer. Okay, do we even want to keep a customer? Well, we can also do every time we have a starting position, we put that as the key, right? So the starting position, so we have a major dictionary with the starting position as the key. And then each starting position will have another dictionary. And in this dictionary, each key is the end station. And the end station is relative to it must be starting from the starting position. And then every time a customer checks out, that's actually not going to work because we need to know when a customer check in. When a customer check in at station A, we also need to know which customer it is. We know the customer and we know the time. All right, then we use two dictionaries, one to track the customer and the other to track the destinations. I mean, two definitely will work because once the customer checks out, we know the distance, or we know the time from the start to the end stations, and we refer that back to the other dictionary that records the average time, and we can update it. So that one is easy to do. Is it possible to do this with only one dictionary? If we do it with one dictionary, then we need this dictionary to also handle both the average time and also the user as well. Which now memory is cheap. Let's use two dictionaries. I think by using two dictionaries, this one shall be resolved fairly easily. All right, let's take a look. What do we have? Again, we are not going to test it here locally. We are going to just write the code, and afterwards we will go to the tests here. So we have two tests to get us going. Anyway, so we are going to do is self dot is this a customer or what do they call customer? That's going to be a dictionary, and the self dot stations, that is going to be a dictionary. Cottage stations might be a little bit misleading. Let's call it station to station. Yeah. So we stat to stat. stat to stat, station to station. So we kind of know what this one is for. All right, so check in. So when we check in, what we're gonna do is we're gonna do self.customer ID equals, oh man, ID is a keyword. Now let's not change it. I mean, ideally, I don't want to do it this way, but yeah, but ID is a, I don't like it. I'm gonna change it. It's fine. I'm gonna change it. So customer ID will equal to the station name and the time, right? So we put a tuple in it, and that's it. Checkout, what we're gonna do is, so this we can use default dict. From collections, import default dict. All right, so gonna be default dict. Each one will be another dictionary. All right, and here we'll just say what do we say? What do we say? So we know the starting station. So this one is a starting station. So here we know the start station and start time equals self.customer ID. We put underscore here, so we know the ID, right? And we're going to do self.stat to stat, station to station. So this is going to be start station, right? Start station, and we can call it end station. What is end station? It's just the station name. What is this? This is previous average, pre-average equals this. Actually, we're gonna call it .get, right? .get station name equals 0. Yep. Now we have the pre-average. Now the post-average. Oh, we cannot do just a single value. We need to also know how many times. So it requires. So it's not. So it's gonna be pre-total and count, right? So it's gonna be pre-total be 0 and 0. This is going to be this. You want to reassign or you want to change it? It doesn't really matter. So we are going to get this. So that's the pre-total and then count, right? So we don't know. Is it possible to? Oh, that's actually not possible. How do I make it? How do I make it nicer? How do I make it nicer? So we have a start station, we have an end station, right? And we shall say, how can we do this with default dict? Well, we are doing it with default dict. Now let's reassign. I like the idea of reassign. So everything is immutable. So I think it'll be more interesting this way. So it's gonna be this, right? And then we know, just call total and count. And this we can say total plus equal to t minus start t, right? This is total, and count plus equal 1, and then we reassign self.stat, and then start station, and we're going to say station name equals total and count, right? And then after we do that, let's also say del self.customer ID, so we can remove this. Oh wait, is that a syntax to remove? I forgot. Let's double check. Let's say a is equal to 1, and say del a. Yeah, I think that's correct. So just so that this will not grow too big. All right, so that's checkout. And to get average, what we need to do is we have total and count equals self.stat to stat station and station. All right, and then we're going to return total divided by count. And that's it. We run a test case first, right here. And then run it, see if this one passes. Show diff. I think we're good. Let's try another one. Input. Oof. Okay. Run code. Yeah, I think we got it. This is a little bit cluttering here. Let's see if we can make it a little bit nicer. For instance, these 2 lines are not necessary. We can just put in here. We'll just say count plus 1. Let's save 2 lines. So we get a start, get this, and then, yeah. Okay. We're ready. We are ready. Copy and paste this one and submit. Pending. Wrong answer. You got wrong answer. What the heck? I thought it was easy, huh? Okay, we passed those 2 test cases. How is this not correct? Every time a new ID comes, right, we record its station name and its time. And every time a customer exits, we get its start station and then we get its start time. And we look into our start station to station. And we go for the start station, right? Now the start station will be a dictionary if we haven't done that yet. And this one we try to get its previous total and count, which if we haven't done that yet, it's going to be like nothing, all right? So now we check out, we're going to reassign this station, this end station name, to a tuple is, oh, yeah, this should be count. It should be total plus. I think I just got it wrong. Why the test case didn't show such an obvious error? All right? And we're just taking advantage. Well, we didn't really research this. Yeah, this one should be right. I mean, isn't this the original test case? How is this not? Hold on. All right, we know which one. We know this is the issue initially, right? So if you run this test case, how is this one like passing? No, that's not how it was. It did not show something like this. This is the original one that we tested, right? Now it shows difference. Earlier, you remember, right? We click it. Don't worry. we have video for it. I'm gonna go back and check. This is weird. I mean, I definitely didn't put it this earlier. Anyway, pending, judging, accept. Yeah, should be right. Okay, I am going to go back to the video and see either I forgot to press show diff or I don't know, or it has a bug or whatever. But anyway, this is the solution. I don't really think there's anything more to say about it. It's pretty explanatory. Pretty self-explanatory. This is an easy question. No doubt. Unless they can do it with only one dictionary. All right, so this is our solution. Very straightforward. Use two dictionaries. Right, two dictionaries. One for handling customers. The station to station, time and number of times the trip has been taken. So each time a customer comes and goes, we use the customer dictionary to obtain the start and end station and the time gap. Then we put this time gap information into the station to station dictionary. In the station to station dictionary, we use start station as the first as the key of the first layer dictionary, and the end station as the key of the second layer. The value of the second layer dictionary is a tuple with total time and number and accounts. Number of times taken, the trip taken. Oh, this looks very bad. I just say total and account, where total is the total time that the trip between the start and end stations, total time that the trip between has been accumulated, and count is the number of times this trip has been taken. To return the average travel time, we only need to compute total divided by count for any given pair of start and end stations. Right? This is O. Yeah, this is ON because we didn't do anything special. Everything is O1 in here. Actually, we should say O1 for all the functions in the class. And we run at 232 milliseconds, which give us an 89% ranking. Okay, that's it for here. Let's take a look at what other people have to say about this question. I think it's an easy one. Maybe medium. You know what? I think they'll label it medium. Yeah, I think they'll label it medium, but we know it's an easy medium, if there's such a thing. Yep, the easy medium. Look at the acceptance rate, and you'll know. All right, hash map and pair, C++, minimalism, plain Python code, dictionary plus counter. Two hash map. Check in and check out. Oh. Total count, user ID. Yep, it's the same idea. It's the same idea. Oh, they use this. Okay, it's not exactly the same idea. They have a route here. They use a route. Which, can we use a route? We can use a route, but our solution, it's more like, it's a try actually, right? It's a try. It's like only two level try. Do you think their method is better? To specify each route. I'm not quite sure. Let's see, minimalism. Yeah, two maps. Let's check this guy. Oh, this looks easy. Pairs. Okay. Okay, that's actually not a bad idea. So ID is used to calculate, yep. Oh, you can use pop. Nice. Nice, you can pop. I didn't know that. So pop it, and then pairs. It's just the time. Frequencies is beautiful. Beautiful. Beautiful solution. Yep, beautiful solution. I like this. I like this. Better than mine. Better than mine. I mean, the customer is its IDs, and he uses a tool of this, right? You don't need to use counter for this actually. But I get it. I get it. I get what he's trying to do. It's a different data structure. I think this is better. Maybe. Well, it's hard to say. It's hard to say. I mean, it's hard to say. Anyway, let's. I don't want to reinvent this wheel because it's all right. So we'll just say I read this solution. I'm gonna put its link. It is basically the same thing, basically the same idea as ours, but its implementation is it's very clean. It's very clean and easy to reason with. Our solution is okay, but the stat to stat dictionary can be a bit convoluted to parse. But I'm not going to change too much, except I like this idea of .pop ID. Yep, this is a good idea. This is a good point. Very good point. Good use of pop. Can I quote it? I think it should be a quote. And then we can comment down here to say good use of pop. Oh, I think it did to me as well. Yep. Yeah, we forgot about the pop. We just run it. I don't think we need to rerun it. We just test this and see if it works. If it works, then you know what? Let's just run it. That's fine. I mean, it doesn't hurt. I'll run it first. Take a look. Diff. Come on. And then submit. Yeah, we use the pop. Yeah, which is I like the pop better than manually removing it. Anyway, all right, that's it. That's it for today. It's a very easy question. All right. Let's see if tomorrow we're gonna get something more challenging. All right. Adios.